what this would benefit from is what we call a comparison model. So in a comparison, we would draw the 7 marbles that Casey has. So Casey here has 7 marbles, and Dylan has 5 marbles. And we would just compare them. And once we compare them, we can see that Casey has 2 more marbles than Dylan. But in this case, since we're not taking 5 marbles away from Casey, it doesn't make sense for us to use any of those models because we're not taking anything away, we are just comparing them. So that is when we would use this comparison model. Okay, so now we're going to talk about the different algorithms. I'm going to over here. We're going to talk about the different algorithms that we can use for subtraction. So the first one that the book talks about is the subtraction, or the standard algorithm for subtraction. So in this one, we have the same first step as the algorithm that we had for addition, where we write the numbers vertically, lined up by place value. So we're going to do this again. So we have 7, 1. Well, let me give myself some more room on top here. So we're going to have 7, 1, 3, 2, base 8. And we are going to subtract 4, 5, 6, 5, base 8. So the second step of this algorithm says to subtract the digits in each place value from right to left. So right to left meaning we just start with our units like normal. So here what we're going to do, we're going to start in the units, so that means that we're going to subtract 2 from 5. Okay, but as we know, you can't take 5 away from 2 because you only have 2. So this is the part of the algorithm where it says when the digit subtracted is larger than the digit being subtracted from, in this case 5 is bigger than 2, we're going to regroup from the digit in the next largest place value position. So the next largest place value is 3. So we're going to take one of these 3's away and we're only left with 2. So in this case, we're going to be left with 2 longs. So in this case, it's easier to think about, well, and before I did this, I had 2 units, 3 longs, 1 flat, and 7 of the next largest unit. So we're going to take 3 and make it 2. So now we only have 2 longs. And then in base 8, we split those 2 longs into, we're going to split 1 long, my apologies. We're going to split 1 long into 8 units. So this 2 becomes a 10 because we're adding 8 units because we're in base 8. So that becomes a 10. So now we can subtract 10 minus 5 is 5. So then we move to the next place value. We do 2 and we subtract 6. Well, again, the digit being subtracted is larger than the digit being subtracted from. So we're going to regroup. We're going to take away a flat here and make it into a long. So whenever we do that, again, we're going to add 8 instead. We're going to add 8. So we do 10 minus 6 is 4. Again, we cannot do 0 minus 5. So we're going to take 1 away here and add 8. 8 minus 5 is 3. 6 minus 4 is 2. So we're going to get 2, 3, 4, 5, base 8. So we can write this out, 7, 1, 3, 2, base 8, minus 4, 5, 6, 5, base 8 is 2, 3, 4, 5, base 8. So I want to point out right here that what we're doing here. So you see that whenever we carried, I added 8 to whatever value is there. So we added 2 and 8 to get 10. We added 0 and 8 to get 8. So this is different than if we were doing this in base 10. So this is how we would do this in base 10. 7, 1, 3, 2, 4, 5, 6, 5. When we subtract them, we oftentimes, we take the 2, take 1 away from the 3 to get 2, and oftentimes we'll put a 1 here because we're adding 10 to that 2. Because we're in base 10, we add 10. So oftentimes we denote this by putting a 1 in front. Well, that's the same thing because we're in base 10, so we're adding 10 is equivalent to writing a 1 in front, because remember that European number system is a base 10 number system. So because of that, this makes a lot of sense. However, 1, 2 in base 8 is 10, right? 1, 2 in base 8 is the value 10. So just keep in mind, this is something that we're not going to do. We're always going to cross off the value and add the base to see what it would look like. Okay. So now we're going to do the Austrian algorithm for subtraction. So this one is a little bit confusing because it's not as standard. It's not something that we learned here in the States, right? This isn't typically what the American education system teaches. However, if you have students who are from other countries, right, this is named Austrian in the textbook, but it's also called the European algorithm. It's more commonly taught in Europe. So just be aware that this is a different subtraction algorithm that different people in different parts of the world will see. Okay, so we're going to use this algorithm, and again, the first step, always the exact same. We're going to take 3, 1, 0, and subtract 6, 7. So this is going to be right in base 10 because it doesn't have a base listed. So this is right here in base 10. So we're going to do 310 minus 67. Okay, so here's what we're going to do. So because we're going to subtract, let me write it out. We're going to subtract it. Okay, so again, we're going to subtract the digits in each place value position from right to left. We're going to regroup using a 1 between the columns. So instead of crossing out things, we're going to put a 1 right here. So that's going to tell us that right here, this is going to be 10 minus 7. And so in this 10 minus 7, we're going to get 3 down here. Okay, well, this is 10 minus 7, so I'm going to erase that. And we're going to get 3 down here. So we group this to make 10 minus 7, okay? And so now, in our next place value over, we are going to have, instead of grouping the 1 with the 0, whereas this is going to actually represent 1 minus 6. So again, we can't subtract this, right? Because the number that's being subtracted is larger than the number being subtracted from. So because we cannot do that, we are going to put another 1 right there. So now we're going to treat this like 11. And treat this like 11 minus 1 minus 6. And so when we do that, 11 minus 1 is 10, minus 6 is 4. So I'm going to clean this up. And this is going to be 4. And then in our hundreds place, it's just going to be 3 minus 1, which is 2. So when we do this, we get 243. So this is confusing a little bit, just because we regroup things, right? So we have 10 minus 7, and then we have 11 minus 1 minus 6, and then 3 minus 1. So it's a little bit confusing if you haven't seen it before, but this is just to keep in mind that this is how we do it. So would this work for subtraction in different bases? So it can work. So yes, it can work. But it's a little bit harder. So it's harder to see how it works. Because, right, we add the 1s right here because we are in base 10, right? Remember, we just had this discussion above on when we subtract in base 10, we typically just add a 1 right here. But if we're doing that in other bases, that doesn't work. So adding that 1 is precisely why this algorithm works. because we're in base 10, we can just add ones in front of things and it all works the same way. So this algorithm can work for subtraction in other bases, but it's a lot harder to see. The notation isn't as clear. So we're just going to stick with this algorithm for base 10 subtraction. Okay, so the next section is on properties. So this ends the how we do subtraction via modeling and algorithms. And so that is all for this video.